Okay, this is part 2 of ratio tables. And now on the front, remember, we were finding equivalent ratios in tables, okay? And this time we are going to graph ratios, so just using the coordinate plane. So the pizzeria credits Remy's account $3 for every 5 pizzas she orders. So complete the ratio table below, then graph the ratios. So for every 5 pizzas, she gets $3. So she now has 10 pizzas, and we have, what do we do to get to there? Well, we multiply by 2, so 3 times 2 is 6. And then how did we get from 5 to 20 pizzas? Well, we multiply by 4. So 3 times 4 is 12. And then how did we get from 5 to 25 pizzas? Well, we multiply by 25. 5 times 5, or 3 times 5 is 15. Okay, so once you complete your ratio table, we are going to graph it. So the question is, how much credit will she have after ordering 15 pizzas? Because as you see, we went from 10, then to 20 to 25. So we have to ask ourselves, 5 times 2 is 10. And then how did I get to 15? Well, I know 5 times 4 is 20, so 5 times 3 is 15. 3 times 3 is 9. She will have $9 credit. And then how much credit will she have after ordering 40 pizzas? So then the question is, 5 times what is 40? It is 8. 3 times 8 will be 24. So we are going to complete this graph, okay? So remember, this is our x-axis down the bottom. This is our y. Starting here, I am going to, because you have to figure out what your tick marks are going to be, okay? And so we are increasing by 5 every time, and so I'm going to go by 5. So 5, 10, 15, 20, 25, 30, 35, 40, okay? And then I think I'll just do the same because we jump up a lot there. 10, 15, 20, 25. We'll stop there. So for 5 pizzas, now obviously we can't go all the way up to this point. It's not quite 5, but about here will be $3. Okay. For 10 pizzas, we have $6 right above the 5. For 20 pizzas, we have $12 right about here. For 25 pizzas, we have $15. And for 40 pizzas, we have just under 25 at $24. Just like that. That's all we're going to do, okay? So look at our next one, number 9. Excuse me. We have the ratio of teachers to children at preschool is 2 to 15. So 2 teachers for every 15 children. So so we will have, let's say we have, and here's how I'm going to do this. I'm going to go to whole numbers. Because if I said 3 teachers, well, 15 divided by 2 is 7.5. We're not going to have half kids, so I'm going to go here to 4. 4 teachers will give me 30 kids. 6 teachers will give me 45 kids. 8 teachers, there we go, give me 60 kids. Okay, we'll do it like that. So we're going to look at our tick marks on the bottom. And so I'm going to count by twos. So 2, 4, 6, 8. And I'm going to count by, I'll just do 15, 30, 45, and 60. It'll be easier to graph that way. So 2 teachers, 15 kids. 4 teachers, 30 kids. 6 teachers, 45 kids. 8 teachers, 60 kids. Okay. Now, I have another one about snow. Snow is falling at a rate of 3 inches every 4 hours. Now, please note that we said inches to hours, but look at my table. It's hours to snowfall, so be so careful. So 4 hours, we get 3 inches of snowfall. Okay, and hours is my X, and snowfall is going to be my Y, because we talked about this when we were graphing and doing our equations, that there are some things that are constant that will not change. You cannot change time. You can change the amount of snowfall will change. It won't always be consistent, but time will always be constant. When we talked about our combining terms, constant. So if I have 4 hours, I have 3 inches. I'm going to divide that. So I want to find 4 divided by 3. So per hour, I get 1.3 inches of snow. So let's say, so my unit rate is going to be 1 hour to 1.3. Okay, so well, let's say 1 hour, and I have 1.3. It is okay if it's not in order on the table, but we'll get it graphed. Don't worry about that. So let's say 2 hours. So times 2. So in 2 hours, I will have 2.6 inches of snow. In 3 hours, I will have 3.9. Okay, so we're going to go by ones on both. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so 4 hours, I have 3 inches of snow. 1 hour, I have 1.3. 2 hours, I have 2.6. 3 hours, I have 3. That's not right. Do you see what I've done wrong? Yeah. How do I have more snow in 3 hours than I did in 4 hours? So we have to figure this one out. What I'm going to say for now. That's not cool. Maybe I did this backward. Let's say this. 3 divided by 4. Maybe that's what I need. Okay. So in 1 hour, I have 0.75. 2 hours, I have 1.5. 3 hours, I have 1, 3 times 2.25. That looks more like it. That makes more sense. So I went backwards. So even though we are graphing it, we have hours over snowfall, but we were dividing inches divided by hours. So I had to go backward. And so this is why this is more accurate. Now, note that sometimes we don't catch these things until we're actually graphing it. And you think, well, it should be linear, meaning it goes in the same direction and doesn't go down because we're increasing. And oh no, my picture doesn't look right. That is a perfect way of catching your mistake, like I just did. So over 4 of 3. over 1 up 0.75, over 2 up halfway, over 3, 2.25. That's it. My last one. To create a shade of purple, Sonia mixed 18 ounces of red paint, 18 ounces of red paint, with 24 ounces of blue paint. Okay, so both ounces. And so let's work out some equivalent ratios in our table. So I'm going to start by dividing these both by 2. So 18 divided by 2 is 9. 24 divided by 2 is 12. It's still equivalent. So 9, she should get the same hue of purple with 9 ounces of red paint and 12 ounces of blue paint. Well, let's do another one. Let's do 18 divided by 3. I'm going to get 6. 24 divided by 3, I'm going to get 8. Again, 6 ounces of red paint with 8 ounces of blue should give me that hue of purple I'm looking for. And so by 2 by 3, how about 18 divided by 6? 18 divided by 6 is 3. 24 divided by 6 is 4. So all equivalent ratios, okay? Oof. They don't give us enough space, do they? I'm going to count by 5s. 5, 10, 15, 20, 25. I know, it's not perfect. And then 5, 10, 15, 20, 25. So over 18, up 24, so right about here. Over 9, up 12, right about here. Over 6, up 8, right about here. Then over 3, and up 4. So as you see, it's linear, meaning that we have equivalent ratios. And that's another thing about when you graph it. If you're graphing your ratios and you know they're equivalent, you should be able to draw a straight line through your points. And as we've done this, all of these, they look like they would have a straight line, and that's what you need to have to ensure that you have equivalent ratios.